where we're going to rotate around an axis that's not the x-axis, but it's still horizontal. Our disk and our washer methods work really well when we're going around a horizontal axis. It can still be used to go around a vertical axis, but it's a little bit more cumbersome. Okay, so we're going to go to the region y equals 9 minus x squared, and y equals 12. And x is going to go from 0 to 3. And we're going to go about the line y equals 15. Okay, so y equals 15 is still a horizontal line, so we're still going to go around a horizontal axis, but I've got these two equations here. Okay, so first I'm going to come up with a sketch just so I can picture it. Here's my x-axis. This is not what I'm rotating around, so I'm not going to draw a little circle here because I'm going to go about the line y equals 15. So I'm going to count it by 3's this time. Okay, so y equals 15 is our axis of rotation. Okay, so I'm just going to put a little arrow around that part there. Here's 18, here's 21. Okay, so now let's write 9 minus x squared. This is 1, 2, 3. Okay, so we're going to go from 0 to 3. So 9 minus x squared looks something, it's our parabola, and it looks like this. I'm only going to graph out this portion of it because that's what we need. And the line y equals 12, which is also right here. Y equals 12. Okay, so I'm going to take these parts here, and I'm going to rotate them around here. So I need to draw a corresponding y equals 12, just highlight it just a little bit above this axis here. So I'm just going to try to draw this lightly. This is like our y equals 12. Okay. And then my 9 minus x squared is going to be reflected. This is just to give me a visual for what my rotation is going to look like. Okay, so now remember, I'm going to draw my inner circle, and I'm going to draw my outer circle here. And I'm going from 0 to 3, so I'm just going to draw a piece here. So it's going to look like, here's my inner, and then here's my outer. So I get this shape, okay, as I'm going around. Oops, sorry, drew this wrong. Here. Okay, and I get this shape here, and it's got this hollow portion on the inside. Okay, so I have an inner radius right here, okay, and I have an outer radius right to my line. Okay, so this is my, I can think about it, this is my outer radius here. Okay, so this is my inner function to my axis of rotation. This is my outer function to my axis of rotation. Okay, so remember our volume equals, we're going to go from 0 to 3 pi r squared outer minus r squared inner dx, because we're integrating this over x. So now my r outer, I have to think, I'm going to go from 15, which is my axis of rotation, to my outer function. Okay, so I want this difference right here. So I'm going to write 15, my axis of rotation, minus 9 minus x squared. My inner radius, okay, it's going to be my axis of rotation minus my function, 15 minus 12. So this is y equals 9 minus x squared, y equals 12. So this here looks like 6 plus x squared, and this just looks like 3. Okay, so I'm going to plug them into my volume. I'm going to go from 0 to 3 pi, right? I'm going to do my r outer squared, so 6 plus x squared squared, minus my inner 3 squared dx, my pi, don't forget that. Okay, so there's some algebra in adding all this stuff up. You have to FOIL this and then combine it with that. This is pi. I'm going to multiply that by, this is going to be 36 plus 12 x squared plus x to the 4th minus 9. I'm going to combine the 9 and the 36 in just a minute, and I'm going to integrate at the same time. So I'm going to get pi times 27x plus 4x cubed plus 1/5 x to the 5th, and I'm going to evaluate this from 0 to 3. So I plug in 3 everywhere I see an x, and I subtract out the 0 everywhere I see an x. And I'm going to get for my volume 1,188 pi all over 5.